Hey guys, today we will be talking about multi-resolution monitor setups on Linux systems. So the ones that run on Wayland and also on X11. And primarily how Wayland is supposed to solve some of the scaling and rendering issues that might come up on X11. But as with everything, there is the ideal case scenario, the idea behind certain implementations, and the real world experiences of users. So if you've ever connected at least two monitors with two different resolutions, say one 4K and one 1080p on your Linux system, sometimes you might experience some scaling issues, weird distortions, where the app windows might look way out of proportions and blurriness can happen and all sorts of problems, which are of course very annoying and you would like to know how to fix them. Let's talk about why this happens and how Wayland is supposed to fix these issues. With more and more people using high-resolution monitors, understanding how scaling and rendering works on Linux might help you to troubleshoot some of the problems and get the most out of your setup. I'm typically trying to get my explanations from the perspective of someone who is like a really beginner in all these type of topics, and I'm trying to introduce the most basic concepts that I needed to understand the further discussion. So first, let's discuss the difference between logical pixels and physical pixels, because for any image that is to be displayed on the monitor, this is where things begin. Logical pixels represent the app design, independent of the monitor to be displayed on, and that is independent of the screen's resolution. They define the relative size and position of elements such as text, button, and images within the app window. So the developers create the appearance of applications by writing the design instructions using logical pixels, because they don't know which kind of monitor the application will be displayed on. And before Wayland came along, it used to be up to the display server to translate logical pixels into the physical pixels, so the actual dots on the screen. Now, considering the meaning of the logical versus physical pixels, rendering in simple terms is the process of translating these design instructions into the actual image you see by converting logical pixels to physical pixels. This is done by creating an image buffer, which is a memory block on your computer that stores the pixel by pixel information of that image, including color, transparency, brightness, and so on. Now the next thing to understand is scaling, because the translation process from logical to physical pixels involves scaling. And that conversion is done by using a scaling factor. This ensures that the content looks the same on different monitors with different resolutions. So for example, on a 1080p monitor, one logical pixel converted to one physical pixel using one-time scaling, or 100%, would look like this. Then on the 4K monitor, if we use the same design rule and just use one physical pixel for one logical pixel, this all of a sudden will look tiny on that screen. And so to avoid this situation, we would apply, say, 2x scale factor and increase that area covered by that pixel to something like this. Now we have a 2 by 2 pixel situation, or 200%, or 2x scaling. And so with the help of the scaling factor, we were able to get the same area covered by the app window on both monitors. The only thing is the pixel density here is different. Here we have 4 physical pixels for the same image representation, but here is only 1. Now, besides scaling, there is one important term to be aware of, and it's called resampling. Resampling changes the size of the already rendered image by either adding or removing pixels from it or to it. For example, upsampling would add pixels to the buffer by using various techniques. It can be just simply taking a single pixel and duplicating it, or taking two neighboring pixels and averaging their value and insert another pixel that is the average of the two. In both cases, it's a mathematical process that recalculates the already rendered buffer. In the downsampling case, we remove pixels by, for example, taking the two neighboring pixels and averaging the result and condensing it into a single pixel, which can result in the loss of detail in the image. But what's important to understand here is that in the process of resampling, we actually modify the data in the original image buffer, which can lead to quality loss or some sort of distortions. Now let's just repeat how scaling is different from resampling. Scaling happens during the initial rendering process when logical pixels are converted to physical pixels, and it happens based on the monitor's scaling factor. That's the process where the resulting image is as sharp as it can be. Resampling, on the other hand, happens after rendering, stretching or shrinking already rendered image. Now let's address the elephant in the room. How scaling and rendering is done on either display server, X11 or Wayland. On X11, the X server renders the content using a single DPI setting. Typically, it's 96 DPI, or dots per inch, or pixels per inch, where the number 96 means that there is 96 dots or pixels packed into every inch of the screen. But that setting can be changed by user. So using that setting, X server creates a single image buffer for all monitors. If monitors have different resolutions or scaling factors, the X server resamples the just created image buffer to fit each monitor. On Wayland, that process is a little different, because on Wayland, it's no longer the task of the display server to render the images. Now it's the problem of the applications. On Wayland, the app renders the content for each monitor, using the scaling factors provided by the composer. And so then in this situation, each monitor gets its own pre-rendered image buffer specific to that monitor. This eliminates resampling and ensures sharp visuals, even if you have mixed resolution setups. So if we compare the two situations, we can think of this as if on X11, the applications are not aware of the different monitors with different resolutions to be present. But X server is aware, and it is up to the X server to make sure that the final buffer is the right size for a particular monitor. On Wayland, however, the display server is not responsible for rendering, as we said, but instead it informs the application about the multi-monitor setup situation and passes the parameters such as resolution to the application. And so the application now becomes aware of the multi-resolution monitor setup. And it's now up to the application to make sure that the final rendered image is the right size for that monitor. Each monitor gets its own pre-scaled buffer, unlike on X11, where initially only one global image buffer is created and then resampled as needed. But that is the ideal world situation. And in reality, even on Wayland, people often experience scaling issues and blurriness and all kinds of problems. So let's discuss the most common ones and the potential solutions for the issues that can come up. So the first and most logical one is the application support, because as we said, on Wayland, applications are the ones that are responsible for rendering. And if the applications are older or not updated correctly, they might not fully support Wayland's pre-monitor scaling idea. The content rendering for each monitor might happen incorrectly because they would just ignore different scaling factors provided by the composer on Wayland. And so the obvious solution here will be mainly working with Wayland-compatible applications. Now the next problem is the fractional scaling, because it appears that on Wayland fractional scaling is not as mature yet, or not as consistent across different composers. So for example, if the rendering requires a fractional scaling, say 150% or 1.5, if you do decide to turn on fractional scaling, what happens is that each monitor will report the DPI and physical size to the Wayland composer. The composer will calculate the scaling factor based on the DPI value provided, and then it will instruct the application to render the image buffer at the nearest highest scaling factor, so say 200. Then after rendering, the composer resamples the buffer to the 150% scaling. And so that's roughly how the fractional scaling is implemented under Wayland. So as a possible solution, you might try to turn on or off the fractional scaling and see which one gives you better results. Now the third possible solution is to just pay attention to the composer you're using, because some of the composers are handling scaling issues better than the others. And from what I've heard, KDE Plasma seems to be doing pretty well in this regard. So that's something you might want to look into. And the fourth and the last issue that can mess up the scaling is the GPU drivers. Because some of the GPU drivers, especially ones like NVIDIA, may not fully support all Wayland features, including high DPI scaling. And so keeping things up to date, drivers, compositors, applications, is possible solution. So now let me know in the comments if this was useful, if I did say something incorrectly, or maybe I missed something. Report your experience under Wayland or on X11, what frustrates you the most, or what kind of solutions helped you to deal with the multi-resolution monitor setup and make it as good as you can, so that it doesn't really frustrate you that much. So thank you so much, and I'll see you in the next one. Bye guys.